Over 200 miles above the Earth, crews continually live and work aboard the International Space Station, or ISS. A technological marvel the size of a football field, the station is a world-class laboratory where scientific research is conducted free from Earth's gravity. But we would not be here if not for another space station from an earlier era, Skylab, America's first space station. Launched in 1973, Skylab was a bold adventure, taking research to new heights, influencing how we live and work in space today, and paving the way for our future explorations into the solar system. 3 Skylab crews completed about 300 experiments to answer questions about our planet, our universe, and living in space. The variety of disciplines included human physiology, materials science, earth science, technology demonstration, and even student experiments. Skylab was America's first foray into microgravity-based scientific and technological research and was an important stepping stone for the design, construction, operation, and utilization of the International Space Station. On board the ISS, scientists use more advanced technology, a foundation of knowledge, and more time to expand upon the important work started on Skylab. Of all the questions asked on Skylab, one of the most important was, how long can humans live in space? The Skylab astronauts lost body mass and bone mineral density due to the lack of loading in the microgravity environment. Today, studies on ISS have shown that sufficient resistive exercise and proper nutrition can maintain bone density on long-duration spaceflights. As medical technologies have advanced on Earth, so has our ability to understand the changes that occur in astronauts during long-duration spaceflight. Skylab had its own factory on board, proving materials processing experiments could be conducted in space. In the microgravity environment aboard the ISS, scientists study crystal growth and fluid physics processes without buoyancy-driven convection or sedimentation to distort structures. These studies lead to lighter, stronger alloys, better medications, and longer shelf life for household products. One of the greatest scientific legacies of Skylab were the astronomical observations made from the Apollo telescope mount. This instrument rack kept Skylab's array of 8 solar telescopes pointed at the Sun during a period of extraordinary high activity. Skylab studies of our Sun gave us new insights into the basic processes of solar behavior, changing the course of modern solar physics. Skylab astronaut Ed Gibson even filmed the birth of a solar flare from space, the first such recording in history. The ability of the Skylab crew and scientists on the ground to react quickly to unexpected occurrences greatly enhanced the scientific bounty from Skylab and was powerful evidence of the value of humans and machines working together in space. Today, spectrophotometers mounted on the outside of ISS measure solar irradiance, the energy from the Sun that reaches Earth. This is of importance to both Earth-based and spaceborne communication systems, as well as to our climate. The Skylab crew took more than 40,000 photographs of the Earth, of value to those involved in improvements of agriculture and forestry, geological applications, studies of the oceans, coastal zones, continental water resources, investigations of atmospheric phenomena, regional planning and development, mapping and development of remote sensing techniques. Since the first mission to the ISS over 12 years ago, over 1 million photographs have been taken of our home planet. There are also specialized cameras, such as the hyperspectral imager for the coastal ocean, which separates light into hundreds of wavelength channels, revealing information about the composition and quality of water and land along the coasts. If we are going to live long-term in space, we need to maintain astronaut health. Studies begun on Skylab led to more advanced investigations today. Ultrasound training methods developed for use on ISS have been used by the American College of Surgeons to teach imaging techniques to doctors. These techniques have applications for diagnosis of injuries and illness in remote locations on Earth, including disaster areas and war zones. In an experiment proposed by a high school student, spiders named Arabella and Anita were brought to Skylab. At first, they had difficulty spinning webs, but when they became acclimated to the space environment, they spun webs closely resembling those that they had spun on Earth. This prompted scientist-astronaut Owen Garriott to observe that the spiders had learned very rapidly in microgravity without the benefit of any previous experience. Recently, a high school student experiment on ISS demonstrated that jumping spiders could also adapt to the microgravity environment and continue to catch prey. The pioneering crews, the operations teams on the ground, and the scientists of Skylab set the stage for the work conducted today on the International Space Station. On board, scientific research continues to benefit all of humanity and prepares us for further exploration in space. But all future journeys will harken back to Skylab, when we first took that long voyage off our planet, seeking answers and overcoming the challenges of space exploration.